right. Good morning. How are you? My name is Andy Walton. I am the VP of Technical Advisors for Densify. And so I'm here today with Alvin Huang from HashiCorp. We're going to talk to you about how to achieve unparalleled elasticity on AWS at the lowest cost, a bit of a marketing term there. So I'm going to go through a few things here today. We're in Vegas, so the Lucky 7 recommendations. There's some best practices and a few things in order to unlock the potential of specific services in AWS, along with some best practices around savings as well. So I'm going to go through those things first, and then Alvin's going to come up and talk about the 7th recommendation, which is specific to some automation around Terraform. And then I'm actually going to show it to you. We're going to do a quick demo if everything goes well here, and let's get started. So the first best practice we see at Densify is aligning the key stakeholders. And you can see that there's a variety of different roles and priorities and folks that are involved in the line of business. So as you get started, and many people in different areas of their journey in the cloud, but the lines of business, obviously, these folks here, cloud engineering and the container platform service owners, those folks have a lot of power. And obviously, they are the leaders in cloud innovation, the building microservices, new applications running in the cloud. They're deploying very quickly in micro-purchasing. So I'm going to talk a lot about micro-purchasing as part of this presentation. You know, as you're using things like Terraform or CloudFormation, and you're specifying resource allocations directly within the infrastructure as code, these folks unwittingly are making actual purchases in the cloud. So we're going to talk about that particular issue. And a lot of times they don't have time or any real desire to manage those resources. App owners and those folks that are in charge of performance, they don't really care about managing costs. So as these services get more and more deployed, centralized IT comes in, obviously, and you've got your platform engineering groups and your container service owners, but in particular, the IT finance folks and central cloud ops will get involved in these types of decisions. And those folks obviously have got specific requirements in terms of IT finance is going to look at the spend as it's going up and increasing, saying, hey, we can save by purchasing reserved instances and savings plans. And the centralized cloud operations folks will also look at this and say, we can save more if we can downsize or actually reduce the amount of services that you're using today because you're only using a fraction of what you've actually purchased. And that will cause that wall to be built between these groups. And obviously that's a big divide that we see all the time, in that central IT wants to control cost, and it's all about performance. Things like, I want my application to perform. The app owner doesn't care about the cost. They just want as much service as possible. And then the containers looking at things like scaling, the auto-scale groups, and node scaling is a concern for them. And of course, from a DevOps perspective, purchasing RIs and things that might get in the way of the whole CI/CD process. So we see this as a divide and something that needs to be solved and acknowledged as we move forward to try to scale out the cloud and actually save money at the same time. This next area, gaining cost visibility, is really a lot of motherhood here in terms of wasted spend, complicated invoices, curve files, trying to understand chargeback and who's using what. You can't even fix those things until you understand who's actually using those services. So the solution here, obviously, and we see a lot of this out there, solutions like Cost Explorer give you visibility into things like daily, weekly, monthly. Line of business chargebacks, the detailed budget management, anomaly detection when all of a sudden something spikes, and creating custom reports. So that's just pure, what I call motherhood types of things that you need to have as part of your whole service. It's just understanding who's spending what, billing up to the public cloud bar, and actually using those resources. Who's doing it and what are they spending on? Same time, back to the other side, the performance side of it, ensuring the application performance. The challenge here is obviously the services and making sure that, as you put certain services in different regions, different availability zones, different services, that it actually matches the service level. And certain applications, production critical versus test dev versus staging, are going to have different service levels that are required as part of your business. Two key questions that we see: are you using the right instance types or service types or container types or whatever it is that you're deploying into the cloud? Have you actually matched the application demand with the correct supply? And of course, this is kind of a motherhood one there, but we've just seen an interesting example in our own environment. Is your application designed correctly for the cloud? We have a big containerized deployment as part of the services we provide, a big SaaS infrastructure for our customers. And one of our key vendors actually just went to a container-based solution, but they didn't go to a microservices-based framework. They just took that application, ported it into containers, and that thing is not performing. So it's interesting, it's like just because you move to containers doesn't necessarily mean that that application is going to be designed and going to work optimally in that framework. So the solution, optimal or optimization tool requirements of your application performance monitoring, your optimization tools, you analyze, looking at the different workload patterns, average, you're predicting what's going to happen in the future, looking at peaks, and then being able to actually benchmark these different resources and saying if I move from one service to another, one instance type to another, they have different relative compute powers, different I/O limits and thresholds that are supported. A minimum amount of data, so it's more of a configurable amount of data that you actually want to look at here, because for some applications it might be I just need a few hours worth of data to determine what that thing is doing. For other ones, if you're going to actually look at changing instance types or moving families, you might need to capture some form of peak business period, so 30 days, 60 days, some sort of a minimum amount of time, a configurable amount of time to say, what is the right instance to match that demand with the supply. Cross-platform recommendations, so if you're moving to different services, different clouds potentially, I know I'm not supposed to talk about that, but we've got customers moving from on-prem into the cloud or from the cloud into on-prem or different clouds and things. The ability to actually change from one platform to the other, that has to be taken into account as part of the analytics solution. Custom or performance thresholds, so this is really all around policy that you want to give different applications that own different lines of businesses, a certain amount of resource depending on what that application is doing. And then, of course, you've got to take into account all the different metrics that are available, CPU, RAM, storage, network, application metrics, the ability to actually leverage workloads coming from something like Datadog or SignalFX, what have you. That's better. Okay. Achieving governance and compliance. So another key area, obviously, as you're starting to track what's going on in the cloud, the challenge is obviously assigning the appropriate tags to ensure that you've got the right people with the right access. So this is really all around roles and responsibilities and saying, I just want to make sure that certain people have visibility into certain types of services. You're meeting whatever internal regulatory compliance and just understanding who is actually doing what. So the solution, obviously, as part of that is to implement or design a solution that adheres to your internal regulatory compliance. And a lot of times that might be just a pure billing reader that includes just visibility reports. A lot of cases, though, the ability to actually identify and fix, and using some of the automation frameworks, we're actually going to show you some of that today, for missing or non-compliant tags. So identifying that they're gone and then actually fixing them. So using a framework like Terraform or CloudFormation to actually say, well, I'm missing some tags and we've got a certain format that something has to adhere to and make sure that owner has got an email address in there or what have you. So the ability to identify it and then actually fix it. So that's a very important part of the solution. Selecting the right resources. Now we're moving into looking at specifics around the actual resources that you're using out there and how we actually fix that through automation. So the challenge, obviously, is the folks that are deciding and they're looking at the application, complex resource requirements, CPU, memory, all the different metrics that you might have available for you, and actually trying to make sense of what that application is doing over time. And a lot of times there's sophisticated spreadsheets folks are using to actually do that. They might be using some of the metrics, some of the monitoring tools and trying to analyze what things are doing over time. So very difficult job to do by hand. On the other side, on the public cloud, on the demand side, there's numerous, and by numerous we mean millions of different combinations of things that you can buy. EC2, RDS, the autoscale groups, container platforms, etc. So trying to match those things up and saying, okay, I've got an application, which region do I run it in? What instance type should I use? What size should I use? What family should I use? Should I buy that as part of an RI or savings plan or on demand or spot? Storage networking considerations, will that demand source, will that instance or what have you, actually accommodate the amount of I/O that this application is going to produce? So all these different considerations, since it can be difficult to actually make sure you're buying the right resources, I'd say it would be impossible without having some analytics to try to figure this out. So when you take this application with all its raw utilization data, consisting of application demand and the millions of different combinations and service offerings, millions of different things that are available, being able to establish application demand patterns predictive based on what something has done in the past and being able to actually analyze it and say, this is what it's going to do in the future. So predictive modeling for the application demand. And then comparing that to the normalized models of supply that are available across all the different families. I saw a chart the other day. I think there's, at least on the EC2 side, there's at least close to 100 different things that you can actually do, and then all the different memory configurations and CPU configurations. So tons of things on the EC2 side, and then, of course, RDS, auto-scale groups, what have you. So being able to match that demand with the supply and optimize those things together. And again, balancing that priority and just boiling it down to the folks that care about performance. You know, they're going to do that and say, I care about this application performing, and I'm going to maintain cost, whereas the IT finance folks are saying, I don't care so much about performance, you got to lower your bill. So everything that you're doing has to be in consideration for these two conflicting groups. Tactics to get it right around EC2 and RDS. So you've got lots of things that you can do actually to balance this performance versus the cost savings. Upsize, modernize, moving to different cross families to better match that application demand with supply, reclaiming resources for things that aren't using them, and then terminate them. On the auto-scale group side, you've got different considerations in terms of mins and max, so the ability to upsize nodes when you need more, downsize them when you're not using them, modernize cross-family, and then the scaling factors for min and max as well. So that's important as well. Container resource optimization, we're seeing this more and more, and obviously people are in different areas of their journey to containers these days. Just pure visibility in terms of the nodes, the namespaces, the pods, and the containers. Just understanding what's actually out there, what they're using in terms of CPU requests and limits, and then ability to actually help them set initial values. In a lot of cases, we see folks aren't actually setting that up. We'll talk a little bit more about that in the next section. And then reserved instance optimization as well as savings plans now. It's obviously causing a lot of confusion in terms of, you know, what should I do? Should I be applying an RI? Should I be applying a savings plan? Should I buy new? Should I renew? Should I let them expire? If I've got convertibles, what should I convert them to? So in the interest of actually saving money for those folks, but it's still matching, you know, what the application is demanding of things. Getting the approval from the application owner is something that we see as just absolutely critical to this whole process. So a lot of cases they talked about just bill visibility, and Cost Explorer and some of the other bill readers are great. But part of the challenge you have with those things is that they'll make recommendations, and it's more of a black box. Your app owners will look at those things and saying, I don't know where this came from, and I don't really care about saving money. So unless you can prove to me this app is going to perform better, I'm not doing it. So part of making these folks comfortable is giving them detailed reports. So this is what we call an application owner report or detailed insight report saying, you know, what was that application looking like before? What's it going to look like in the new instance? Assuming, you know, again, you're either upsizing, downsizing, and giving them the evidence they need to say, I'm comfortable with that change. Make them happy. In terms of making that happen, so our engine is obviously designed to help do this in terms of the human readable application owner reports for the application owners saying, don't change my applications, don't change my resources, but they'll approve that change, and this is what we've seen, if they're comfortable with it, that they have proof in making sure that the application is not going to suffer for it. And the other side of it, from a cloud operations perspective, you can't hand a whole bunch of recommendations to somebody and say, okay, go out and make it so. So this has to be automated. And obviously, Alvin's going to get into that component a little bit further, but taking machine-readable actions and actually being able to insert them into the whole CI/CD process, the whole framework, so the folks that don't have time to actually do and change, say, 200 different recommendations, that can be added right into the whole CI/CD framework. So the quality answers integration means they can automate and then, you know, essentially sleep better at night, not having to do more work. If we get into the whole containers discussion here, and it's very interesting, and I'm going to hand this off to Alvin after this component here. Problem we see and the challenge right now, and again, resource optimization, just understanding, and a lot of it is just visibility in terms of what are these resources actually using today. So just clear visibility into what is actually going on. Let's say human errors in the resource specification. It's not so much an error, but it's more of guesswork in a lot of cases, saying I'm going to set some initial values for CP and memory requests. And I'm not quite sure why I'm setting them like that. It could be tribal knowledge. It could be, the other applications are sized like that. In some cases, those specifications aren't set at all. And then looking at, the more you can optimize the containers themselves, elasticity management around the whole autoscale groups. So if you're specifying and understanding what's going on at the individual container level, the resources at the autoscale group will become that much more elastic and actually scale better. And I'll show you how that actually works here. That's part of the challenge. So here's an example. On the right-hand side, you've got the resources hard-coded as part of a manifest file, CPU and memory for the resources, requests, and limits. And the dev and app owners are typically saying, okay, I'm going to size this the way I always have. The challenge you have is the containers get deployed and the schedule actually sets up. You'll see at the bottom, we liken a lot of these workloads to Tetris workloads. So you can see, or maybe not so much, but you've got workloads that are sitting there actually using a fraction of the resources that they've actually been provisioned for. There's an example of the problem that creates. So your node resources are then allocated, but they're not actually used. So this is an example of how much has actually been allocated. And the actual utilization looks like that, a flat line compared to what's actually out there being configured in the environment. So that's a big example of a lot of waste that we see in these containerized environments. So if you use predictive analytics to actually help you do this, and then hard code, well, not hard code the resource requirements, actually use lines of code, we call infrastructure or optimization as code, in the manifest file, say do a lookup instead. And so what that looks like then is analyzing the actual workload patterns of the containers themselves, and then figuring out from a predictive perspective, okay, we can figure that out, and then inside whatever templates you're using, CloudFormation or Terraform or Ansible or whatever configuration management or infrastructure code tool is you're using, what will happen is the scheduler will become much more efficient in terms of how it actually schedules the resources. So you'll see that they're using less resources inside the nodes themselves. The scheduler will start packing workloads closer. So become more of a game of Tetris where it's now starting to squeeze workloads more efficiently on the nodes that they're actually running on. And then as that happens, more recommendations will come out of the engine saying, all right, well, you've actually deployed the wrong type of resources for those nodes themselves, and that you could be running in general purpose, and it would be better to running in something like a memory optimized or CPU optimized, what have you. So different recommendations now to make the nodes more efficient as well. So this is all great, but how do you end up managing all this stuff at scale? And so the answer is automation in terms of, okay, how do I do this balance between elasticity and using most uses of my resources in the cloud while at the same time trying to save money? So I'm going to have Alvin come up here and continue the conversation, and then we're going to get into the actual demonstration and show you that. So, Alvin. Oh, thank you.
All right. Thanks, Andy. My name is Alvin, and I'm a release engineer at HashiCorp. If you haven't heard of HashiCorp before, we're the company behind tools that you've probably heard of or used in the past, such as Vagrant, Packer, Consul, Vault, Nomad, and Terraform, which we'll be talking about today. An overview of what we'll be talking about, we'll start off by looking at what some of the differences are between how we provisioned and managed infrastructure in the past, or our traditional data centers, and then how we'll manage our modern data centers, such as those in AWS and in the cloud. We'll look at if there is a better way to manage these things in the cloud, and then finally look at some of the organizational challenges that you may encounter as you make this transition to cloud and how you'll go about overcoming some of these challenges. So to start off, provisioning infrastructure in the past was fairly easy. Most of your data centers had fixed sets of resources, whether this is CPU, memory, number of servers, what have you. IT operations was kind of your gatekeeper to procure, validate, and provision all these different boxes. So these would be very large boxes that would sit in your data center, and the procurement process would be very lengthy. So they would have to create a procurement through like CDW or whatever infrastructure provider your company uses, and then depending on how long the compliance and approvals take, this may be months or half a year, 6 months to get this infrastructure for you. And then we'll look at what happens when your application and infrastructure extends to multiple data centers. So instead of just having one data center, let's think about how we'll manage these multiple data centers in multiple regions, and then how it extends to a hybrid cloud environment where you have half your workloads in a traditional data center and half of them in AWS as you're having this digital transformation and moving from on-prem to cloud. So your traditional approach was your application owners would create some sort of infrastructure request ticket saying, I need a box with 4 CPUs and 8 gigs of RAM for my new application. They would create this ticket in Jira or ServiceNow or whatever ticketing system you have. The IT team would kind of crank through this queue, and they would go through a GUI, whether this was in OpenStack or in vSphere, to create these different boxes for you, or maybe there's a golden image in vSphere that they just clone for you or something like that. And depending on what sort of approval gates you have in there, this may be something that could take a couple hours or a couple days, depending on how big that queue was. And then eventually they would give you an IP address that you could deploy this application to. But as we move to the cloud, we see that the workflow is fairly similar. We'll have the application team create a ticket. The IT team would crank through the queue. They may look at using the AWS console to click through and create these EC2 instances for you or whatever resources you may need, and then give you back the IP address or whatever resources you may need, such as databases or things like that. But as we move to the cloud, we see that a lot of people start to use this API-centric approach. So things like the Boto3 Python library or SDK and like the Go AWS SDK, those sorts of things, and CloudFormation and Terraform, using an API approach for a large cloud like AWS where you have hundreds of services is much easier to manage than going through the GUI and clicking through and trying to provision all these things for your users. And if we think about how infrastructure works in the cloud, we've moved from this static sort of infrastructure in your traditional data centers where to get one web server to connect to one database server, it was creating an IP tables rule or creating a firewall rule in your Palo Alto or Cisco or whatever firewall you may use, to this more dynamic world where we just had Black Friday last week. Let's say you're a big e-commerce company and you have an Instant Pot that was going for $40 or something, right? Everybody loves Instant Pots nowadays. So everybody's sitting in your servers and you need to scale up from your normal 20 VMs or 20 containers all the way up to, let's say, 200 or 2,000, right? So the ticket-based approach doesn't work quite well for this. You don't really want to create 200 tickets for the IT team to go ahead and provision these new hosts for you, and then another 200 to spin them back down. So this is why you would use a tool like Terraform or something that is API-driven so that you can very quickly change a count or some sort of variable to change it to 200, and then once Black Friday is over, you can spin it back down to your normal workloads. As we look at a modern web application, it gets much more complicated than just spinning up an EC2 instance for you, right? So you may have an S3 bucket that holds your web assets. You may have a load balancer for your front-end web servers, a load balancer for your back-end web servers that connect to your databases. And managing this sort of dependency between resources is really hard in your head. So if you can imagine somebody going into the UI, they would have to map out all of this and remember to, okay, I need to go ahead and create these EC2 instances before I can create the load balancer that load balances between them, et cetera, et cetera. But it turns out that modeling your modern data center complexities are very similar to just modeling a relational database of sorts. We would heavily rely on the tooling to do this mapping for us so that we don't have to map it out for ourselves. So the question is, how do we capture all those things that we normally point and click in a GUI to spin up something for our customers or our application development teams in a more codified way? And is there a better way? So our tool, Terraform, is a tool that can help you do this. And it does cloud infrastructure automation using infrastructure as code. And then there's also cloud compliance pieces in there if you're using something like our Terraform Cloud SaaS platform that has governance and RBAC and things for team-based sort of infrastructure as code deployments. So over the course of the past couple of decades, software engineers have basically settled on a particular sort of workflow for their code. This is creating a feature branch, working on your feature, merging it into develop or into master, however your artisanal sort of Git flow works in your company. But this sort of Git-based approach can be applied to infrastructure as well. And this is what we mean by infrastructure as code. And then there's also a piece called Sentinel that we have that does policy as code, which is making sure that your configurations fit into specific rules that your company has set out. And if they don't pass these gates, then the Terraform tool won't apply them. And then finally, we have a whole slew of open source providers that allows a rapid creation and support for all your different pieces of infrastructure. So let's say you have your web application and you're using EC2s in AWS. Let's say you're not using CloudFront, but you're using something like Fastly for your CDN because that's what all your other web applications are using. And then let's say you're using Cloudflare for your DNS instead of Route 53 or something. So Terraform has all these different providers, and these providers are just plugins to different SaaS platforms, platform as a service platforms, infrastructure as a service platforms. And you can define all of these into one configuration file. So when you're deploying a new web application, you can quickly see, okay, I have an EC2 instance, I'm going to create a DNS entry for it, and then I'm also going to hook up or point the CDN to this new EC2 instance, all in one configuration file so that it just gets deployed all at once. So if you've never seen Terraform code before, this is just a very simple example. There's a provider block that defines what provider you'll be using. So in this case, it's AWS, and you define a region. There are some required parameters for some of these blocks, such as your AWS secret key and your access key. And then you have a set of resources, which are just different objects in that particular provider. So in the case of Cloudflare, it would just be DNS entries rather than AWS instances in this case. The next use case is cloud compliance and management. So as we look at using something like Sentinel, Sentinel is our policy as code framework, which allows teams like the security team or the finance team to define, let's say, what instance types your company can use, or what instance families they can use, or what CIDR ranges they can use, those sorts of things. And anyone who deploys or tries to deploy Terraform code that doesn't fit into this rule set, it won't allow it to deploy to your infrastructure. So you can reduce risk with this sort of central point for compliance and management. And then you can also reduce cost, which makes all the finance people happy by eliminating all this overspending that you may have. So let's say people spin up 20 instances for development. Well, you can use Terraform and use its CLI command, destroy, to kind of tear those down at the end of each workday or things like that so that you're not leaving them hanging out for however long and just accumulating, just costing your company money. And then finally, like we had talked about before, you can increase productivity with a single workflow for a bunch of different providers. So you don't have to write special tooling to talk to Cloudflare and talk to Fastly and then talk to AWS. You can use one sort of framework and use one tool, Terraform, to define your resources for all those three providers, and you can use this same workflow to deploy to many different things. So people can manage, GitHub teams, GitHub resources, such as your repos, your repo owners, those sorts of things with the GitHub provider. And finally, the third use case is self-service infrastructure. So this allows us to have increased productivity using a library of modules for technical and non-technical users. So modules are just groupings of what you define as like a web application, for example. So we've talked about this Cloudflare, Fastly, sort of AWS stack. You can define all this in one module, and then you can just expose particular parameters that gets passed to this module for your non-technical users to use. And then also, let's say you have subject matter experts in your company, like your DBAs or your networking team that knows a lot about VPCs or RDS, and other folks that want to consume RDS don't know as much about those configuration parameters or how to configure it. Well, your DBA team can create these modules for other people in your company to use and just expose whatever parameters they feel is safe or would allow the application owners to complete their job. And then like we had talked about before, we can reduce risk with our Sentinel policies, which is a gate between the Terraform plan and apply phase, where Terraform plan will give you an output of what will happen when this infrastructure gets deployed. And the Sentinel runs in between it and basically checks, okay, is this allowed or not? And then the apply phase is actually applying this infrastructure to AWS. So you can think of this as a dash dry run sort of flag for other CLI tools. So we'll move on to talk about some of the organizational challenges that you may run into and how to overcome them. So as we move to the cloud, there are many different groups and many different stakeholders in moving to AWS and what they really care about. So you have the developers that care about making sure that their deployments are efficient, making sure their application doesn't have downtime, making sure that the environments are controlled between dev, staging, prod. There's the security folks that care about access control, whether their policies are enforced, and whether there's risk and accountability and audit trails for what's happening. And then there's the finance and corporate folks that care about your cost and productivity and how you're scaling as you move out to the cloud. So we'll dive into these three groups in a little bit more detail. So your developers and operators, for efficient deployment, they think about how do I deploy this thing repeatedly and have it be the same thing every single time. So the solution with Terraform is infrastructure as code. So there's reusable configuration that is shared across operators. And using our modules, you can allow these developers to deploy a single stack that looks the same, whether developer A deploys it or developer B deploys it. The second thing that they care about is my infrastructure up when I need it? So for development purposes, you don't want developers to come to your cubicle and ask you, hey, can you spin up this box in dev so that I can use it, right? So one way to do this is have self-service infrastructure. And you can create these modules for developers to use and for them to create this infrastructure themselves. And they're allowed to create this whenever they want and on their own terms. And then finally, are the right applications in the right place? So figuring out how to do cloud management and having a consistent workflow across dev, staging, QA, and prod. And using Terraform, all you really have to do is change a couple different parameters. Like let's say between the different environments, nothing should really change besides maybe your instance sizes or the CIDR ranges that your dev and staging prod QA sort of environments are separated into. So just exposing those parameters and keeping everything the same allows you to have everything be consistent, right? So one of the main pain points that I'm sure a lot of people have encountered is, oh, why is this working in dev and not in QA? Or why do I have this 12 gig box in dev, but I only have this 4 gig box in production, right? It doesn't make any sense. The second group is security. So access control. How can I control who can provision? So if you're using something like Terraform Cloud, you can develop groups for what we call dedicated workspaces. And these workspaces are just sort of containers or not modules, but groupings of environments that you can deploy. And different groups can have restricted access to deploy particular workspaces. Second, we'll look at policy enforcement. So our deployments in compliance. So using our Sentinel framework, security can work with auditors to figure out what is allowed to be deployed in your environment. And then you can implement these at the time of provisioning so you don't have to clean up afterwards. And then finally, risk and accountability. How do I track all this? You can leverage the logs and version control to monitor who provisions what infrastructure. And we can lean on your normal GitHub workflow or Git log to trace, oh, somebody created this new instance and it was much smaller than what we needed, and this correlates to something in CloudWatch that's showing a bunch of 500 errors, right? So you can quickly see, hey, somebody committed this code, they changed this instance size from an extra large to a medium, and now we're seeing 500 errors. This is probably what the problem is, instead of somebody going into the UI and creating something and you not having an audit trail or knowing who did what and why that web server is now throwing a bunch of errors. And then finally, the finance and corporate folks care about cost control. So how do I keep spending down? In Terraform Cloud, we have this thing called cost estimation. And at the point of provisioning, it'll be able to tell you, hey, when you're moving from a T2 micro all the way up to an M4 large, the cost difference is going to be X amount. And this is a quick check to see, oh, am I allowed to do this? And two, how much money is this going to cost me or my company when I do this? Two, productivity. Are my operators working efficiently? So to make operators work as efficiently as possible, people in the sort of DevOps sort of role want to make self-service infrastructure, right? You don't want to be in the business of spinning things up for other people. You want to enable them to spin things up themselves and not hinder their progress. And then finally, scalability. Are we meeting our end users' demands? So if we create modules and we create these sorts of groupings of resources and then allow developers to deploy it on their own, then they can deploy it on their own time and on demand as they wish. So they don't have to come and ask the SRE team or the sysadmins to do this for them. So we've looked at how to solve some of the management challenges between the three different groups using infrastructure as code, self-service infrastructure, and then finally cloud management and compliance. So how do we tie this all back to Densify and using their recommendations in your infrastructure? So this is kind of the workflow that you'll work with if you're using both Densify and Terraform. Your operators will start off by writing a Terraform configuration file using the Densify module. And the module is basically an interface for Densify's analytics, and the module will return you an instance size that it recommends for your instance, whether this is over the course of 30 days, 60 days, 90 days, what have you, looking at your past workloads and determining what they will be in the future. It'll give you a sizing back. Two, your Terraform will construct a plan based on this configuration file. 3, it'll do the Sentinel check to make sure that it passes all your compliance requirements or financial requirements. And then 4, it'll go ahead and do the Terraform apply, which is changing that instance size in AWS. And then finally, the circle completes with Densify pulling this data for infrastructure for future optimization. So, you can deploy this on, let's say, a nightly schedule, an hourly schedule, what have you, and then whatever Densify returns back to you will, those sorts of recommendations will change every time you use Terraform to deploy. So looking at cost control with Terraform and Densify, I kind of look at this as a two-pronged approach, where pre-provisioning, we have Sentinel policy that requires you to use a Densify instance type. So if you have Densify and you want people to use it in your company rather than just hard coding your instance sizes, like Andy was mentioning, you can create a Sentinel policy that enforces that, hey, you must use the Densify module rather than hard coding your instance sizes. And then you can also enforce budget restrictions using Terraform's cost estimation. And then post-provisioning, you can use Densify's machine learning platform to develop these optimized instance types. So looking over the course of time, Densify will give you a recommendation of what it thinks your application will need. And then as Terraform runs and reruns over time, it'll basically apply these recommendations back to your infrastructure. So I'll bring Andy back up to kind of finish this off and give us a demo.
Great. Thanks, Alvin. Okay. So I'm going to skip by this one here because I've got an actual example here. But I did want to show you actually, just before I do the demo, what the framework looks like. So we call it CI/CD CO, continuous optimization. So the way that the whole process would work in a normal world is Densify analyzing and learning how to actually look at your instances here and actually learning that behavior over time based on what's happened in the past and building a predictive model. Now, if you do this essentially manually, you say, all right, Densify's come up with an optimization recommendation. It could be upsizing, could be downsizing, changing node sizes, what have you. If you go and make that change and don't build that into the whole framework, what will happen is the next time that Terraform template gets applied and it gets rebuilt, the infrastructure, it's going to wipe out those changes you made. So you have to build this into the whole DevOps process here, the whole CI/CD. So the way we do that, the way I'm going to show this to you is essentially, we'll take that human readable output, we'll take the machine readable output. I'm going to actually demonstrate a Slack integration here. So some of our customers don't actually even bother logging into the interface, they live in Slack. You subscribe to certain applications. The application owner can get the recommendations and see exactly what changes are planned for his application or her application, as it were. And then the actual machine-readable code can be built into this whole process. So it'll be the cloud engineering folks can actually automate these things. So we call this continuous optimization. And then as those approvals are actually generated and we actually get those things, and the deployment will go out, the instance over time now becomes self-optimizing. So instead, again, of hard coding that right within the template, by having a lookup saying, well, what should this thing be on a daily basis or more frequently or less frequently? Again, according to Alvin, is like some applications you're going to do this more often than other ones. We become now continuously optimized in the environment. So, Sean, I'm going to get you to switch over here. I'm probably going to have to log back into my machine here. And let's actually show it to you live. While I'm doing that, just a quick show of hand. How many of you folks are actually using some form of infrastructure as code? Terraform or CloudFormation, what have you? So lots. And just in terms of the containerized world and microservices and things, how many of you are using containers or on a journey to actually containerize your applications today? A few, a fair number here. Okay. So let's just focus on entering in the right password here. Okay, so let's get rid of that. So what I wanted to show here was a couple things. I've got an infrastructure that's actually running right now. So I'll just show what's actually running in the cloud. I've got 4 instances running here, and my Terraform actually management VM here. And that corresponds with 4 systems I'm actually looking at right here. And we've analyzed these ones. So the first one I wanted to show you is this one here. So Densify has analyzed this particular instance, and this is actually running, and this one's running hot. So currently, it's deployed on an M4 large, and the recommendation is to take that to a C5 extra large, something with a little more compute power. So what you're seeing here on the bottom is a machine learned pattern of this particular application, pulling in data from CloudWatch or Datadog or Splunk or SignalFX, whatever, augmenting the analytics that we have in all the different metrics. So we'll get the standard ones from CloudWatch, and we'll get other things as well, depending on the sources of the data. And it builds an hourly model of exactly what that application is doing over time, and essentially looking at average sustained activity, peak activity. And then policies would dictate, how you actually want to treat that thing. So this one's actually running right up against the limits here in terms of CPU, hence that recommendation. So this one needs more resources. There's another one above that one that's an opportunity for a downsize. So essentially, this one's running on an M4 extra large. Its recommendation is to move to an R5A, so memory optimized. This one here, you can see the before and after. So blue means this is what its predictive pattern is. This is what it's going to look like in the new world. Again, all this information here is available through these app owner reports as well. So this might be an example of a test dev workload. You might not want to run a production application this hot. And the whole idea, of course, is that you're going to treat different applications differently based on a policy. So not everything is, as all things being equal. So here's my Slack view. So I've already run the get notifications here. I've got a couple applications I'm subscribed to look at. There's my web service. There's 4 components. I can click on show details. And what that should show me is the 4 instances that require some form of attention. So there's the first one here. This is an upsize. Again, there's that recommendation, M4 large to a C5 extra large. I can add the report to the channel here. So again, if I live in this interface, I might want to actually look at the actual recommendation before I approve it. So that's going out and doing a build me my report and tell me what the changes are. And that takes a moment on a wireless network. So there it is. So that's tough to read, probably. I'm sure you can't hardly see it, but the details are in here, exactly what the changes are, what's the policy based on, so how much, what's the predicted uptime of this application, what is it using before and after, so the detailed workload patterns, details around the system information. There's additional information in here as well around things like, what is the effort level, because it might have different storage or networking capabilities, et cetera. So we want to say, some of these changes might be more difficult to implement than other ones if it, say, requires a different storage type as an example. And some of those recommendations might be automatically disqualified. So the app owner report is the thing that gives the app owners the comfort that they actually can make that change. So I'm actually going to approve this recommendation. So I'll approve that. And then the other one that we saw here was the downsize the M4 to the R5A. So I'm going to approve that one as well. So let's go back to the applications here. You see nothing has changed yet. It's still sitting here. So parameter store in this case is my centralized area. This is where I'm saving the actual recommendations. We've got customers using DynamoDB. In this case, it's an area where you can actually put the recommendations here and then track them over time. This framework is actually useful as well for the tag compliance. So we built an actual framework using things like CloudFormation with parameter store or Terraform with parameter store. Say, well, what's the history of these tags here? So you can see there's an approval in here. It was originally an M4 large, and now it's a C5 extra large. And then there's additional tags. I won't get into that for the demo today. I'm just going to run out of time, where you can actually get into the whole tag compliance visibility and then automating the changes if you make changes to these tags as well. Okay, so nothing has changed at this point. We're still sitting here. So I'm going to go into my Terraform window and just hit oops. Let's try that again. I think that thing actually died. Okay, so I'm going to do this. Hang on one second. It's just a timeout here. So let's try this, because I'd like to actually make this change here for you. So let's do this. We'll reconnect to this thing. My authorization. Live demos, there we go. So log back in, hit Terraform, apply, as Alvin was saying. So now it's actually going out and checking for the approvals through all the instances that are being managed by these things, and it's found 2 things to actually change here. So it says 2 to change. If I cycle back up, you'll see the 2 specific instances, 131 and 202. I have to hit yes. And so that's now going to go out there and do its work. And if I just come back to this view here, and of course, I've got a couple things running because I've actually, let's do it. So you'll see some instances changing. Now, of course, in production, this would be all subject to certain change windows and things, and you might have a more formal process through ServiceNow or Jira where you actually have to open up a ticket. Because bouncing instances in the middle of the day is typically not something that you would want to do for production applications. The idea is that you can actually create the automation and then work into the framework of how your company actually makes changes to things. And this applies directly applicable to the containerized strategy as well. So we should see these things up and running. And there we go. So there's 202 now running on a C5 extra large, and there is 131 now running on an R5A. So it's as simple as that, but it does require, we don't bend the laws of nature or anything like that. So that's pretty much the end of the demonstration. Let me just flip back to the PowerPoint. And so Alvin, you might as well join me up here as well. So specific breakouts, there's a number of additional ones here for Hashi. If you'd like to come, maybe Alvin, you'd like to talk about these things?
Yeah, so we have a bunch of different breakout sessions, and we also have a booth. So if you want to learn about anything more about the Terraform tool or learn about some of our other tools, such as Console for service discovery and how it connects to AWS Cloud Map, there's a session on that. That is tomorrow. That's the Net 2.11 session.
Okay. And so if you'd like to see more, and I'll just open it up for any questions that anyone might have.
Yeah.
Yes?
So in your example, your demo there,
Yep.
Densify made changes to a TFR file or a TF file?
Yes. Could you flip back to Sean, I don't know if you're still there. Can you flip back for me? I actually meant to show that as well.
Does that require the file to be annotated in some way so Densify can find what it needs? Or?
Well, I'll show you. We're showing the screen there. So there is your hard-coded instance types. This is instance type M4 large.
Yep.
So if I actually comment this out, so I've got a different one here that's basically a lookup. And this is a simplified version of the whole thing where it's a call into Densify through our API to say, what should that thing be? The other components that's important as well, there's additional things in here around the tags that we're adding, and you can also add fallback workloads. And we talk about elasticity of adding or removing resources. You can define fallback workload types if you decide that, hey, this approval is not what I wanted to see. So if I go back in here and actually say, and I can reverse it through this simple interface here and say, unapprove that thing, or I want to move back to something. You'll see inside the parameter store here as well, if I go back here and say, let's check out. And so that thing's already updated to a 3. And so I'll look at the history of that, and you'll see it's actually been reversed. So the whole component of giving more and taking it away as necessary is all supported through that functionality.
Got it.
Quick question. You have a lot of workloads on Kubernetes. So you mentioned, is it on? Hello? Yeah. We have a lot of workloads on Kubernetes, vanilla Kubernetes on AWS.
Yep.
And you mentioned Densify works alongside, Kubernetes.
That's
and
correct, yeah.
We don't generally manage like instance types directly. We use Kubernetes to do that.
Yep.
So a couple of questions. How does that work? And in your recommendations, like cost recommendations, what have you, or instance type recommendations, do you have microservice level recommendations? Because each microservice has different needs, right?
Yes, as a matter of fact, yeah. So I was just showing the EC2 demonstration here today. So we have full support for Prometheus, or at least to collect data through Prometheus and other mechanisms, but typically it's Prometheus, and that could be in AWS or in other clouds or through OpenShift. And the recommendations, you'll see full visibility at things like a namespace and the pod level, so just what's running out there. And then all the way down to the individual container level, you'll see recommendations saying you've currently configured this amount for CPU request and limits. or memory, what have you, and what is the recommended size based on the learned behavior of that container. And again, the policy might say that I only need to look at this one for a day because it's only running typically for a day, or I might want 30 days. And again, the different mechanisms for pulling back that data will give us different data. Like CloudWatch will give us 60 days, Prometheus, I don't remember. It's a certain amount of history, and again, the policy will dictate as to how much data you want to actually have before you actually make any sort of changes, typically a minimum amount, right? He's coming with the microphone. It's like Phil Donahue.
Hey, I had 2 questions about Sentinel. Can it be used for doing things like, say, don't replace my production database, or would that be managed in just standard Terraform? And then also, can you set up rules to enforce that resources have tags?
Yeah, so you can set up I'll take that second question first. Yeah, you can make sure that you have to have you can say you have to have a tag block, or you can say, you have to tag it with a particular tag or a particular sort of regex sort of match. You can do it that way. And then for your first question, sorry, what was that about? That was.
Can you set up rules to stop replacement of a production database?
I don't know if you can set up rules to prevent that. That is a particular like configuration parameter in Terraform, though. Okay. So you can basically keep the database. It's like the destroy on or keep on destroy or something.
Okay.
Yeah. Prevent destroy.
Prevent destroy. Cool. Thank you.
He's a Terraform expert in the front row.
Yeah.
It doesn't stop you from doing it, but when you do it, you'll get an error instead of it actually doing it. It'll say, can't do this. You have a lifecycle rule saying prevent destroy.
You may have mentioned this, but just in case I missed, I'm sorry. For the Terraforms, does this density works with CloudFormation as well?
Yes, it does, yeah.
Okay.
Yeah, any technology infrastructure is code, but works very well with Terraform, as you can see, yeah. Okay, if there's any other questions, you can come on up and talk to Alvin or I after the fact, and certainly come and see us at the booths in the main hall and the expo in the Venetian. Thanks very much for your time today.